Thanks, Fred. So happy to be here and represent BASF. And as the topic of our entire endeavor here is connect, I want to connect to a few talks from yesterday. And we saw a quite interesting study of the evolution of the Allotrope Foundation and its members. And what was quite interesting to see was Donto showed us was basically that a lot of industry members, but also equipment members, left the room when the chemical industry entered. So I know we'll add a lot of complexity to the Allotrope Foundation. As you can imagine, we have a very complex workflows and also much more, let's say, variety in our workflows compared to the pharma industry. And we have much less regulation. And that makes it also a challenge for us to drive standardization in our company. And there was also another question around how far is BASF actually when it comes to the adoption of standards. And I would say it's a pretty mixed bag. So we have areas where we have adopted to the Allotrope standard in a very nice way and integrated that into our systems. We have other areas in the companies where we use the R&D ontology to map our efforts we have proceeded also in the standardization of the human input, where our laboratories are more, let's say, regulated by D norms, which are very open, as you know. So and with that in mind, you can already hear that we centered a lot around standardizing human input, but now we are really rethinking the way we have set up our data management ecosystem and are heavily focusing on the vertical integration of our equipment. But the equipment piece is only a minor piece in our overall workflow, where we, of course, care a lot about equipment connectivity. And here I don't see a big problem for us. But when it comes then to the equipment integration, the data validation, but also the various integration methods, real-time versus batch, and also the data mapping, which is a lot of the data mapping is still done manually. And there's a lot of effort that the user usually doesn't recognize. And then we talk about software system integration across our various systems, and also about the process and workflow design. And all of these aspects have needs for standardization in our labs, and that's what we are heavily working on. And what's the motivation actually behind? And so before we put a lot of effort into getting the human input standardized, but when you look at our laboratories, we have 3 times more equipment, so 3 times more information coming from our lab equipment than we actually have lab technicians in our labs. And what also makes it a huge challenge for us is we have a large diversity in equipment. We are ranging from simple engineering equipment to synthetic setups to chemical safety equipment. And if you look at it from a systems point of view, you can actually say on the hardware side, when we look at the life cycle of things, we are looking at a life cycle of more than 10 to 15 years. But when we look at the software side of things, we are currently in a, let's say, upgrade cycle every 3 years, and that is ever increasing. So for us, it makes most sense to make use of the asset equipment in a standardized form in order to be flexible on the software side. And for us, open source and open standards on the equipment side need choice on the software side. And through the implementation of the open standards, we also enable our labs to be more flexible in their choices of software. And also we make sure that the integration pipelines we build can actually be reused, which is actually the biggest pain at the moment for our data scientists and data engineers. And with that, we also make sure that proprietary formats are no longer limiting our data analytics efforts. So yeah, and, as I already mentioned, labs no longer look like labs 20 years ago. So here's an example of a lab nowadays. This is actually an application testing lab for the dispersions and resins divisions on coatings, coated surfaces, where we analyze surface properties, mechanical properties, as well as hardness, gloss, and things like that. And so you can see this no longer resembles really a lab. It's a fully automated testing facility with individual modules. And we also need standardization of these individualized models that we sometimes even build on our own. Next one. And with that challenge, I would like to move to the technical side and hand over to Tobias.
Thanks, Kathrin. So just briefly, I think this slide summarizes a little bit what we also heard yesterday and today. So what we found, or what we find in the lab, is typically a rather complex environment. So the people in the lab, they have to deal with different equipments, different file systems, different formats. And I mean, what we are typically observing in the lab is that the lab technicians especially do a kind of first data integration into their tools. Yeah, and those tools are most probably from Microsoft. And Excel is here a rather favored tool for many. And but also like specific SDKs or analysis tools are in place which are used. Yeah, and all these brings super much complexity. And when we now look here on the challenges we see for equipment integration, of course, as Kathrin already mentioned, we have thousands of instruments from hundreds of different vendors, and now the question is how to deal with these various formats. Yeah, and secondly, what is also kind of focused at the moment, since we are a huge company, unfortunately, we not really know what kind of assets are in the lab. Yeah, and we also don't really know how these kind of assets, devices, instruments are used. Yeah, and this is quite strange from the point, you know, for our plants, for example, in BASF, we do really a lot to optimize everything. Yeah, but we know if we are looking into the lab, there, I mean, the assets, the instruments. Yeah, it's very difficult here to optimize and be more efficient. Yeah, so this is definitely also something what is interesting us to learn more about the usage of the instruments. Yeah, and of course we also ask the question. I mean, with this kind of architecture you see here, or these kind of workflows, the reuse and integration of data is really challenging. Yeah, and we spend really a lot of money and resources in order to extract data from these systems, to clean up data. Yeah, and in the end, the question is always, is it worth it? Yeah, what is in for the lab also? Yeah, what is in for the data scientists? And this is always a really challenging question. Yeah, and as you can also imagine, it's very difficult in this scenario to be able to compare data and share data. Yeah, because the individual labs use in principle always their own format, own data model. Yeah, if you can switch to the next. And so what we are envisioning here in principle is that we standardize the data which is coming from the lab. Yeah, but in our opinion, I mean, just to standardize something is not really bringing value at its own. Yeah, so here we really try to use the data we gain from that in order to, for example, learn something about our usage and asset utilization. And secondly, what is also quite important is that we make the data fluid. Yeah, so standardizing the data increases the accessibility. And secondly, what I will show also on the later slide, we can then use this data to optimize specific things. And I think this is key here to really get these kind of standards into the lab. Yeah, we have to bring something beneficial for each lab in order to argue and to convince those labs to deal and work along this kind of data standardization. You know, go to the next slide, please. Yeah, so just to give you a brief example, what kind of activities we are at the moment working on. Can you go to the next slide? Yeah. So the first question where we started to work on is in principle, okay, we have now the instrument data, we have the files, how do we convert this kind of stuff? Yeah, and I think there are different strategies. Yeah, so you can use like commercial solutions like Kathrin Science or Cytera or like Zontel, for example, for these kind of approaches. We also are looking here into, let's say, self-developed, tailor-made on converters for translating instrument data to RSM. Yeah, of course, this is a tedious way, yeah, especially if you have to deal now with proprietary formats, yeah, because in order, yeah, you have to resolve or you have to knock the format open kind of to do that. Yeah. Anyway, next slide, please. I mean, we are doing that at the moment, and we are able to transform those kind of Excel and instrument outputs into ASM, and this is working fine in my opinion, and it's robust. However, again, the question is a little bit what is enough for the lab, and where does we generate value? If you go to the next slide, please. And here, as I mentioned before, we really see, or we really think it's important to combine now the on the one hand the data standard to automation. Yeah. So the people in the lab, and here we carried out some POCs last year, where we not only ingest the data from specific lab instruments. We standardize them into ASM, for example, but we also transfer those kind of instrument data, result data, for example, automatically to a separate preparation robot or to an ELN, to a LIMS system. And I think here is really key, as I mentioned before, to get benefits, to increase efficiencies in the lab. Yeah, and you always have, if you're talking, or if you have the lab focus or the lab perspective, you have to look for these kind of efficiency gains. Yeah, because the standard alone, as I said before, is not sufficient in my opinion. And the data standard is a kind of enabler in this sense. Yeah, and I think so data standards are helping us to make the data liquid. This is quite important then for use cases, also like not only automation, but also like for data science. And I think with that, I would like to hand over to you.
Okay. And as Janet already mentioned, it's very important that the standard is actually not just a standard that's there, but it's standard that's lived. And we have built a Allotrope community who Fred is hosting internally in BASF, where we also centrally manage model availability, model updates, but also the demand for new models to keep this community alive within the company. So there, of course, we tackled some problems already and were quite successful in some automation cases, which is really nice. But we also have quite some challenges still, and I was very happy to see the presentation from Agilent on combining the OPCOA initiative with the, or at least presenting a pilot on that with the Allotrope simple model, because that really resonates the challenge we currently see in our high throughput devices and also in our pilot plants, where we are looking really at this more than 20% of our assets are connected to PLC. We have the characteristics of timestamp data. We really want to automate this in a standardized way, and bringing the ASM together with the communication protocols of UPCOA would help us a lot there. And also having a standardized model description for all our PLCs would help a lot. So next slide. And here you can see that we also built our own automated small plants, these high throughput plants that you see. And here you can see also the OPC output structure, all the plant-related sensors, and also the timestamp data. And there we have the challenge to generate a generic model of our plant topology, also be consistent on the sensor namespace, and also have a standardized aggregation schema for the hierarchy of the individual sensors on the plant level. And not only the PLC part is a challenge, as I already mentioned, chemical industry has a lot of standard, or not even standard operating procedures called DNORMs, which leave a lot of room for interpretation, I have to say. And we made a very significant effort in my previous division to standardize these operating procedures in a way that we aggregated them to so-called test methods, then derived individual parameter lists that can be reused for the individual process steps or the characteristics of the method. And then on a parameter level, standardized all the parameters that make up the final test method. It's not according to the Allotrope standard, but it shows you that we are also on the human input side are heavily working on standardizing our methods. Yeah, and I can only emphasize that in the age of AI, data quality, data variety, and open data is still the main factor. We will not get next slide, please. It's still, according to a recent research report on AI and machine learning, that the number one barrier hindering the adoption of AI and also the return on invest of AI is still the lack of confidence in the data. And we've seen that in so many projects where we took historical data and could not reproduce the findings that were represented there. So this is why it's very important for us to make that extra effort to standardize data and make sure, next slide please, that our models are effective, that we develop, and that we have also the accurate training data to make sure that we don't have a bias in our data or overfitting. And the best way to do that in the lab is really utilizing the equipment data that's available free, kind of. And with that, we are open for questions.